Hi everyone. Let's study in bridge engineering inspection technology, ultrasonic method for testing concrete structures, internal defects. This knowledge point. First, let's look at this picture. The bridge in this picture collapse caused by internal defects in the structure. Therefore, it is necessary test for internal defects in bridges. In engineering, commonly uses ultrasonic method for bridge concrete detection. Internal defects in the structure. The main testing contents involved include location and extent of voids and loose areas inside concrete, crack depth. These two tests. In this section, we will focus on explain these two items. Ultrasonic method for internal defect detection in concrete structures can generally be divided into two categories. The first type uses thickness vibration transducers, conduct planar testing. The second type uses radial vibration transducers, conduct drilling tests. First, let's learn testing steps for loose areas and voids in concrete. Step 1. It is advisable to first refer to on-site construction records and appearance quality conditions, or during use. After quality issues arise, preliminarily determine the approximate location of internal defects in concrete. Step 2. Based on preliminary measurements, conduct detailed testing on suspicious areas. When testing loose areas and voids, tested location of the component should have one or two pairs. Mutually parallel testing surfaces. Testing scope in principle should be larger than the suspected area. At the same time, under the same conditions, normal concrete areas. Conduct comparative testing. General comparison of measuring points should not be less than 20. Use the planar testing method and using drilling or pre-embedded pipe measurement methods. The following points should be noted. First, when the tested part of the structure has two pairs of parallel surfaces, can use a pair of transducers on two pairs of mutually parallel surfaces. Conduct comparative measurements, as shown in figure 4:1. Second, when the tested part of the structure only one pair of parallel surfaces available for testing, can use a combination of parallel testing and oblique measurement methods. Arrangement of measuring points is shown in figure 4:2. Third, for large volume concrete structures, due to its large cross-sectional size, to shorten the testing distance, improve measurement sensitivity, drilling or embedded pipe measurement methods can be used, as shown in figure 4:3. Step 3. In acoustic parameter observations, identification of abnormal values. When in the measured concrete, acoustic parameters of certain measuring points, judged as abnormal value, can combine with the distribution of abnormal measuring points and waveform condition, determine concrete internal non-compact areas, and the position and extent of voids. Next, let us learn detection of concrete crack depth. The ultrasonic method can be used for detection depth of concrete cracks. When testing, there should be no accumulated water in cracks and other sound-conducting inclusions, and concrete near the crack should be fairly homogeneous. In this lesson, we take the cracks that the structural cross-section is not large and can use parallel testing as an example. Testing was conducted. Detection steps. Step 1. On two measurement surfaces, arrange measuring points at equal distances. Use direct measurement method to measure sound time point by point, as shown in Figure 4-4a. Step 2. Plot the relationship curve between sound time and distance for the measuring points. See Figure 4-4b. End of curve segment A. Intersection position with the beginning of section B is the area reached by the crack. Step 3. For the area reached by this crack, then use the method of densifying measuring points. Conduct parallel testing. When the connecting line between the two probes intersects with the crack plane. As the probe moves, sound time gradually shortens. Sound time remains unchanged when not intersecting. During actual measurement, as long as there are 3 points with unchanged sound time, consider the sound time stable. Can accurately determine crack depth HL. In the end, I will summarize the content of this section. In this lesson, we have focused on learning ultrasonic method for testing concrete internal defects, respectively mastered. The principle and steps of ultrasonic method for detecting the location and range of voids and loose areas inside concrete, as well as the depth of cracks, through the learning in this lesson. Hope you can, during the actual detection process, maintain a rigorous and serious attitude, more observation and practice, to locate concrete structures, internal defects, and conduct scientific testing.